Yes. Recording started. Now you can start your presentation then.
Yes, sir. Good morning, everyone. Today, I'm going to do a presentation on registers of 8085 microprocessor. What are CPU registers? First, in last semester itself, we had learned flip-flops. Flip-flops are used to store single bit of data. So, to store n bit of data, we will require n flip-flops. So, for n bit registers, we will require n flip-flops. But what are these flip-flops doing inside these registers are, they are used to store data. We know CPU is a brain of computer. It does three major tasks: input, processing, and output. During these three activities, surely it has to store either the data or the instruction it has to process in some space. So register assists them in doing that. Either you can store the data or instruction temporarily or permanently inside these registers. And the registers, depending on the work they do and depending on their accessibility, they are classified into 4 categories. Am I audible, sir?
Yes, you are audible. You continue.
Yes, sir. Categories. First one, general purpose registers. Registers B, C, D, H, and L are GPRS. GPRS is abbreviated as general purpose registers, and those are 8 bits. Now, usually the registers are of 8 bits wide, and some special purpose registers, that is, registers pairs and stack pointer and program counters are of 16 bits, and they are used to store, and remaining other registers are used to store 8 bits of data, and they are used to store data temporarily. Register pairs, we have 6 GPRS pins, and among them we can probably make just 3 pairs. Those are BC, DE, and HL. B, D, H are MSB. What are those MSB, B, D, H are?
Students, kindly type it in the chat. For what question Danya asked? BDH. What is MSB here? She told it's a 16-bit data. Okay.
Yes, sir. I got response from Antony Surya, sir.
Yes. Most significant bit or byte?
Yes, sir. So Antony Surya has given the right answer. Most significant bit. During the opcode while
Antony Surya, whether it is most significant bit or byte?
Most significant byte, sir.
Yes.
Okay. Most significant. During the opcode, while we need to refer a register pair, we can make use of these MSBs, B, D, or H, in order to represent the register pairs. Next one, special purpose register. Now we have discussed general purpose register, which are used to store data. They are used to store data, the normal work which registers do. They don't have any additional functionalities. That's why they are categorized as general purpose register. They can store data, that's all. 8 bits of data at a time. And they can be grouped together, namely BC, DE, and HL, the 3 valid register pairs available in 8085 microprocessor. Using these 3 register pairs, we will be able to store. If single register is allowing us to store 8 bits of data, when they are paired together, we can say that it can store 8 plus 8, 16 bits of data at a time. Next, special purpose register. The 2 special purpose registers we have learned in 8085 microprocessors, A and F. A refers to, already it is present in the side. It's okay. What does A refers to?
See, kindly respond, students. Yes, very good. Antony Surya, Logus Nigam, many of them are typing accumulator. What about in classroom 2? Sorry, classroom 1? Yes, Akash, Pratiksha, Karthikeyan, many of you are typing accumulator.
Yes, all have typed the correct answer. Accumulator register. It is also a register, but it has special functionalities. First one, it is also used to store 8 bits of data. That is the first point. Since it is named special purpose register, most of us would confuse that it can store more bits of data. Not so. It has the same 8-bit capacity, but the functionality differs. First one, it has as an intermediate storage and allows data transfer between microprocessor and external peripherals. We know CPU, we cannot work just with CPU. We need other external hardwares, monitor, keyboard, mouse, all those comes under the categories input and output devices. for a computer, for a CPU to be connected to all these peripherals, and in order to transfer data between these peripherals, we'll be need of some registers to store those data, and that is accommodated by accumulators. And during ALU operation, the two main registers which work so hardly during the ALU operations are A and F, accumulator and flag register. First, during ALU operation, if I'm going to do simply an addition operation, if I'm going to do 5 plus 7, which will give me the answer 12, surely one of these operand must be stored in accumulator. And second one, the second second operand can either be stored in the specified register, or if you haven't specified any register, then it will by default take a temporary register. We will learn about that temporary register in the forthcoming slides. Just now we have completed accumulator register, and the result of that operation will be stored in accumulator. Okay, and it is denoted as A register, A. And why did I say immediate storages? To allow data transfer between the microprocessor as well as the external peripherals. And then also performing these early operation, it allows the data to be stored in them. So we say it is used as an intermediate storage. Did I make the point clear, or is it confusing?
Students, is it clear? The three important special additional capability what Danya told, is it clear to all of you? Yes? Clear. Antony Surya is typing clear. Lovely. Many of them are typing clear. You can proceed, Danya.
Yes, sir. Next, flag register. It is also an 8-bit register, but what it does different from the accumulator register is, accumulator register stores the data and it fully does everything related to storage. And flag register, what it does is, it will give the status of those results which is stored in accumulator register. So after ALU operation, I said right, during ALU operation, the two important register which works day and night 24 hours, accumulator register and flag register. So here after ALU operation, the flag register, which is denoted as F, the F register gets affected. It defines the status of results stored in A register. It consists of 5 bits. You might wonder, it is an 8-bit register, but how come they have defined just 5? Yes, very good question. The 5 registers, the 5 bits are defined here, and remaining 3 bits are considered to be don't care. And the position of the don't care is also specified in the slide. I will explain that one too. So first, let us see this picture. Flag register. It consists of S. S stands for sign bit. Z. Z stands for zero flag. A C stands for auxiliary carry flag. X denotes don't care condition. From last week we have learned this. X denotes don't care condition. Thus, don't care condition denotes just 0 or 1 or both 0 and 1s. What is the correct answer? What does don't care condition, don't care terms define? Either only zeros, only ones, or both zeros and ones? I haven't received any response yet.
Students, kindly type the answer in chat. Don't care means whether it must be always 0 or it must be always 1, or it can be either 0 or 1. Yes, Sajesh typed both 0 and 1 in second classroom. Yes, Logus Nega, many of you are typing. Yes, you can
Logus
proceed.
Nega, Dikshan, lovely journey. Thank you for your response. Yes, first sign flag. Sign flag is set to be 1. Here we define 1 and 0 as set and reset. 1 for set and 0 for reset. So sign flag is set to be set when the result is negative. How come do we say that a result is negative or positive? Do you have any idea on that?
Yes, any response? 0 means positive. Antony Surya is typing.
Yes. Other than Antony Surya, no one is giving answers. Kritika has given the answer too. Okay. Next. 0 flag. 0 flag, if the result is 0, the 0 flag.
Actually, here it must be 1, Danya. Don't worry. Okay.
Yes, sir.
Z equal to 1 here. Okay. If result is 0 means set. Okay. No issues. Okay. You can continue.
Yes, sir. Here sign we have discussed sign flag. Depending upon the position, depending upon the number which is present in the most significant bit, we can say that it is a negative or positive number. If it's a negative number, the sign bit is said to be set. And second one, here the slide, I'll have to correct this one. Z, zero flag is said to be set when the result is 0, else it will be 1. Okay. And AC, auxiliary carry flag. There normally during an addition, we'll have just 2 carry, auxiliary carry and normal carry. That refers to as carry. Auxiliary carry, when there's a carry from lower nibble to higher nibble, we say that is an auxiliary carry. If my result is having such carry, then I can say that my auxiliary flag bit will get set if there is a auxiliary carry. Else, if I'm not having, then the flag bit will be reset. And carry, if there is a carry from the most significant bit from a number, from a result, then I can say that the carry flag will get set, else it will be reset. And parity flag, depending upon the number of ones present in that result, I will be able to say that the parity flag will be set or reset. So if I'm going to say parity bit is set, then I can say there are even number of ones present in my result, else there are odd number of ones present in my result. Next, here is an example. We have already learned this opcode add E. Add E is to add 8-bit of data present in the register E with the accumulator content A. The result is stored in A. Already these 2 points we have discussed in the special purpose register under accumulator. And if I'm going to assume that this is the result which is to be stored in accumulator register, this is how the status or the value will be stored in F register. X, I already defined that X refers to don't care, and you all have given me correct answer that X refers to either 0 or 1. The possible 2 values which can be given, that's all. Next, PSW. We haven't seen this as an external hardware present inside the CPU, but we can say it is a combination of already existing one. We had already seen that special purpose registers are accumulator and flag register. So when these two special purpose registers are combined together, we say that it is PSW. It is abbreviated as program status word. And it is accessed by instruction push PSW and POS PSW. Non-accessible registers. Okay, we know that registers allow storage of data and instruction, but every time we cannot make use of the registers which is present in CPU. How come we are saying those are accessible and non-accessible registers? Is while we are writing opcode, if we are able to refer that register in our opcode, then those are known as accessible. That is, anyone as a programmer will be able to refer to that register. Those are known as accessible registers. But if I couldn't use those register pairs, if I couldn't use those register in my opcode, if I couldn't define them, then those are known as non-accessible registers. Here, the hardware and software, now it will get split. The 4 main non-accessible registers which are present in 8085 microprocessor is MAR, MDR, IR, temp, W, and Z. So first we'll go with MAR, memory access registers. It's a 16-bit register. From the name address, we can say that it is 16-bit because address is of 16-bit data. In order to accommodate that address, we'll be in need of a register which is of 16-bit length. That's all. Here, program counter. In the next forthcoming slides, we will discuss in deep about program counters. Now we'll have just an overview of that. So from this diagram which I have given here, instruction decoder. First, I shouldn't have read instruction decoder. It is a last step. First, control signals. Control signals will make the program counter to increment. What does that increment and decrement do in this program counter is, depending upon the total byte of instruction, total byte that an instruction occupies, a program counter will get incremented. And so if I'm going to say, if I'm having a 3-byte instruction, it will get incremented by 3. And it will point to the next instruction's address. So the present address. Now we say that program counter is used to point to the next instruction address. Then who will point to the present instruction address? That work is done by MAR. It is an internal register. MAR, memory address register. It will hold the current address. What does this address is? In the memory, we'll have different instructions stored in them. And to access those instructions, we'll be in need of the memory's address. So that that address is stored in MAR. That's why it's passing via address bus. And once it has reached its memory, there will be two classifications. That is, if I'm getting out an instruction, because we say that this address is just to refer that location in that memory, and that memory might contain a data or an instruction. If it's gonna be a data, it will directly go to general purpose registers and do their task respectively. Else, if it's an instruction, it will go via MDR, which is gonna be discussed in the next slide. MDR. Memory data registers. It's an 8-bit register, because I had said since MAR is used to store address, it's a 16-bit. But MDR is it's not either, it will have just instruction. That is of just 8-bit. So it is just an 8-bit register. After fetching that instruction, MDR will pass that instruction to the instruction register. Instruction register, it is used to store instruction, and it will consist of instruction which we have typed. Our opcode is nothing but our instruction. So that will get stored in instruction register. But I have one more question to ask. The opcode which I type is an assembly language. Will that be understandable or readable by the computer? My question is, will the opcode be readable or understandable to the computer or the CPU?
See, on reading the particular byte, whether the computer knows what operation it has to do. No, they are typing no.
Yes, sir. I've got response from first 3 responses are Sugant, Logasneka, Pavitra. Thank you. Okay, instruction register. After this, I already said that it consists of instruction, and you all said correctly that opcode cannot be read directly by the CPU. So it will have to get decoded. And for that, we are having decoder here. That's all. The entire process is being accompanied by memory as well as the non-accessible registers. Those are known as internal registers. That's why we are not able to access them. They are used for just CPU's internal purposes. And temporary register. W and Z registers. We had already seen them during SIR's class. During the exchange operation, W and Z registers are used. Those are temporary registers. From the name itself, we can say that those are temporary registers, which are not accessible because they come under the category non-accessible. So by default, they will not be accessible to the user. They are exclusively used for internal operation. The one thing which we will have to get clear is that internal registers are something which cannot be accessible by the user. That's why they are known as non-accessible registers, since they are being internal. That's all. These registers can store up to 16-bit of data, because W can store an individual 8-bit and Z can store an individual 8-bit. So 8 plus 8 by default will get 16-bit of data. Lower byte, as usual. We had already seen during the register pair, the first one gets the higher order and the second one gets a lower order. So WZ, among WZ, we have higher order bit in W and lower order bit in Z. Temp register, which is also a temporary register, but this is where we can find this is during the ALU operation. I had said during accumulator, while explaining about speciality of accumulator, I had said if we haven't defined any register, because one operand by default will get stored in accumulator, but what about the other operand? If I haven't defined any register, by default CPU will take one temporary register and it will store that second operand into that temporary register, and then it will, after getting the result will get stored into accumulator. This is all the process we have learned, but there are some intermediate register which is present in between them. First one, the temporary register will store a value which is being temporary. If I haven't defined any register, it will get stored into temporary register. And we had seen that result will get stored into accumulator, but before getting into accumulator, first the result will get stored into this temporary register. So during ALU operation, we can find this temporary register. See, near ALU, we have temp register and flag register. Flag register defines the status, and temp register will store the result, and that result will get reflected back in the accumulator. That's why it is like a mirror image. But it's a temporary one. Next 16-bit. Up to now, except register pairs, we haven't seen any 16-bit register. But this is the first one which we are going to see under 16-bit registers. Stack pointer, LIFO. What does LIFO mean? We had already studied in data structures. What does LIFO mean?
Yes, they are typing last in first out, Danya.
Yes, sir. Super. Okay. I've got response. Thank you so much. It is a reserved area of memory in RAM where temporary information might be stored. A 16-bit stack pointer is used to store address because if it's a 16-bit, what does it can store? Surely an address. So it stores address of the most recent stack entry because we had all.
Danya, can you hear us? I think your voice
Sir.
is breaking. Yes, yes. You can continue.
Yes, sir. Yes, sir. Then the return address is used to get pushed into the stack. Okay, 1 minute. Program counter. I had already told about program counter. Can you all remember in which slide or under which topic I said about program counter? It's just a guess. If it's right, so cool, or else we'll go with this one. Can you remember in which slide I said about program counter? I said in the next slides we'll discuss in deep. Can you all remember? Yes or no? That's all. If yes, can you define that?
Antony Surya typed MAR. She typed
Yes,
MAR.
she is right. Under MAR, we discussed program counter because with the increment in program counter, which will point to the next address, MAR, which holds the current address. This was the line which I said, and Antony Surya Kritika has given the right answer. Thank you so much. Here, program counter. It acts as a pointer to the next instruction. We had already seen. Increments program counter depending on the nature of instruction. Depending upon the byte occupied by that instruction, it will increment the program counter. If it's a 1-byte instruction, it will increment by 1. If it's a 2-byte instruction, it will increment by 2, such that the program counter always points to the next address. Let's summarize what we have learned. In this entire internal structure, we have learned only about registers. First one, general purpose registers, GPRS, those are 8-bit registers. And second one, following that, we have stack pointer, which is stack pointer and program counter. Those comes under 16-bit registers, SP and PC. Next one, accumulator and flag register. Those are special purpose registers, each of 8-bit, A and F. And I had already said A and F can be combined together, but it's not present as in hardware. But they can be combined together, and we have a term for that. Can you remember that term? Combination of accumulator and flag register. Super. Kritika has given the answer. Kritika, lovely.
Yes, Sajish typed in second classroom.
Vishali Logasnika. Thank you. Thank you, Sajish. Special registers, A and F. And we have temp registers, which are marked red in color. Those are non-accessible registers. Temp register, which is temporary register, instruction register, temporary register W and Z, all those comes under non-accessible register. And the last point which I've given is PSW. It's a combination of A and S, but it's not present separately as an hardware component inside the CPU. That's all. Do you have any doubt regarding this? Any questions?
Students, you can ask any questions.
Can I ask you a question, Ma? Rajaratnam here. Good morning.
Good morning, sir.
Anyway, I'm going to ask everybody. So I'm just telling, right?
Oh, yes.
How is PC incremented? Is it taken to ALU and incremented, or how is it done? Because PC is 16-bit, ALU is 8-bit. How
Yes,
can
sir.
a PC be incremented? You said PC will be incremented every instruction, for every instruction, right?
Yes, sir.
Okay. How is PC incremented? Which component increments the PC?
Control signal, sir. Whether control signal does
No,
that
look
to
at the diagram and say. Look at your register diagram and say. Have a
Mm.
look. I mean, answer can be wrong. Nothing wrong in it. You are learning now, so it
Yes,
is
sir.
nothing wrong if you say wrongly.
Increment,
Have a
decrement, that.
incrementer, decrementer is a 16-bit or 8-bit.
I think it's an
Look at the size.
16-bit, sir.
Okay.
Yes,
fine.
very good.
Okay. You also said I have one more question, right?
Yes, sir.
Depending upon the size of the instruction, the PC is going to increment, right?
Yes, sir.
Let's say I have a 3-byte instruction, LXIB 2000, LXIB 2000. I'm not sure about the opcode of LXIB. Let me say it is 21, right? So if I have to feed the data, how will I enter? In one memory location, I will enter 21, then 00, then 20. That's how I enter, right? Opcode.
Yes, sir. Yes,
I
sir.
think it's 11, sir. Upcode is
Okay,
11.
11, 00, 20. That's how I enter the opcode into my kit, right?
Okay, sir.
So 3 different memory locations, right?
Yes, sir.
First location, 21 will be fetched, right?
Yes,
You
sir.
said depending upon the size, the PC will be incremented.
Yes, sir.
So if it is incremented, it is going to point to the next location, next memory,
Yes,
next
sir.
instructions memory. But
Yes,
I
sir.
have to get that other address also. How it will be done? Are you getting my question?
No, sir.
Yeah, fine. You said once the instruction, the PC will increment to point to the next instruction based on the size of the instruction, right?
Yes, sir.
That you are clear. If it is a
Yes, sir.
single byte instruction, PC will get incremented by 1. If it is 2 byte, it is going to get incremented by 2. If it is a 3 byte, it is going to get incremented by 3. That's what you said, right? That's
Yes,
what in
yes,
the
sir.
slide also, right?
Yes, sir.
So I have a 3 byte instruction, right?
Okay, sir.
LXI B 2000, right?
Okay, sir.
Okay. So
Okay,
how
sir.
many byte instruction it is?
3 byte.
3 byte. First byte is opcode, which is 11,
Yes, sir.
right? It is going to occupy a 8-bit memory location, which is also going to have an address, right?
Yes, sir.
Opcode is going to have an address in the memory.
Yes,
Then
sir.
the other 2 bytes are 00 and 20.
Yes,
Correct?
sir. Yes, sir.
Lower byte is 00. That is
Higher
also
byte.
going to have an address. 20 will also going to have an address, right?
Yes, sir.
So I have fetched the opcode first, right?
Yes, sir.
Only 1 byte can be fetched at a time, right? Because ALU data bus is only 8-bit. So obviously I cannot fetch all the 3,
Yes, sir.
right?
Yes, sir.
If PC is going to be incremented by 3, then how will I fetch my other 2 bytes?
Using the address latch enabled, sir.
No.
No, sir.
No. You have to find the answer and let me know, right?
Okay, sir. Done, sir.
Is the question an interesting question? Obviously, it cannot be 3 straight away, right?
Yes, sir.
Then you cannot fetch 00 and 20.
Yes, sir.
So obviously, every memory location has to be incremented by 1, right? I fetch 21,
Yes,
then
sir.
I decode. Once I decode, I understand it is a 3 byte instruction. So during the next cycle, I will get the second lower byte. Then during the next cycle, I have to get the higher byte. If I have to access the memory, then program counter has to point to give that address, right? Then only I can access the memory, right? So
Yes, sir.
I have
Yes,
to
sir.
fetch all the 3 bytes. Then my program counter is point to the next instruction. Then the next instruction will be opcode will be fetched, right? If you go step by step, byte by byte, then it is always 1 byte at a time, right? Ram sir, correct?
Yes, sir. Actually, வந்து மெட்டீரியல் நம்ம என்ன போட்டுக்கோம் சார் ஆஃப்டர்
Yes, sir.
ஃபெச்சிங் அண்ட் இன்ஸ்ட்ரக்ஷன் அப்படின்னு போட்டுக்கோம் சார்.
After fetching the instruction, that's
Yes,
important. During the fetch, it is always 1 by 1. You can straight away say it is always
sir.
incremented by 1, right? And the decode phase, it will be
Okay,
incremented.
sir.
Okay, ma.
Yes,
Okay,
sir.
ma. Thank you very
Students in
much.
classroom 2. Okay, what discussion so far gone is Rajarathan sir asked.
Sorry, I am not in the second class. I will log
Yes,
into
sir,
my
yes,
second class also.
Yes,
Sorry.
why how the program counter get incremented during a fetch operation. Fine. Say for an example, if it is a 3-byte instruction, you will be having 1 byte as opcode, the remaining 2 as either data or address. Correct. So the program counter keep on incrementing by 1 only. Fine. So during fetch operation, it will get incremented by 1. Fine. So that it can take all the 3 bytes. So after fetching the whole instruction, it points to the next instruction. Okay, that's what mentioned in the material. After a fetch operation, the program counter get incremented based upon the instruction size. Okay, is it clear for all of you?
So it will be always 1 byte at a time. Very well done. Thank you so much.
Thank you, Danya. Now, Shivakumar, you can start presenting. Danya, you can move from, you can left from classroom 2. Okay, your presentation is over. Okay, thank you. Very good presentation done by you. Yes. Shivakumar?
Sir, am I audible in both the links, sir?
Yes, you are audible. Can you mute in one mic, one classroom and speak?
Okay,
classroom
sir.
mute பண்ணிட்டு பேசுங்க.
Sir, now is it okay, sir?
Yes. Do it in the reverse way. இன்னொரு கிளாஸ்ல மியூட் பண்ணிட்டு பேசுங்க.
Sir, I got disconnected from other meet, sir. Wait, I will join again, sir.
Oh, you have to join. Okay, fine. Yes, I think Shivakumar is joining to meet link now. Yes. Shivakumar,
Yes, sir.
can you hear my voice?
Yes, sir, I can hear you, sir.
Yes, you are available in 2 classrooms. Okay, kindly unmute
No,
in
I'm
both
joining to
classrooms.
class 1, sir.
Okay, you just unmute in classroom 2 also.
Sir, am I audible?
Yes, you are audible. Okay, have you unmuted in classroom 2? Shivakumar?
Yes, sir, I am unmuted. Sir, I am muted, sir, in classroom 2.
Yes, you unmute and speak so that we can know in both classes you are audible.
Sir, now it's audible, sir.
Yes, fine. Now you are audible in both the classes. Fine. Okay, now you can present now. Click on present now in both window and present the entire screen. That's better way so that you won't get confused. So click on present now. Click on entire screen.
Sir, am I presenting in
Shivakumar, I think, wait a minute. You logged in the same class, I think.
Sir, no, sir, different classes.
No, in classroom 1, you have logged in with two IDs. Right? That means same ID you have logged in 2 times. Kindly check it. In classroom 1, there are 2 Shivakumar showing for me.
Sir, in class 2, am I there, sir?
Yes. Shivakumar?
Yes, sir.
Wait a minute. Yes, now you can continue, Shivakumar.
Sir, is the slides are visible, sir?
Yes, you are visible in both classes. Your slides are visible in both classes. Whether Shivakumar voice is audible in both classes, can you people type it in the chat? Classroom 1, classroom 2. Yes, fine. You can continue, Shivakumar.
Okay, sir. Good morning, one and all. Now I'm going to present my topic on timing and control signals. The first timing and control signals, we can see control signals, which are ALE, read bar, write bar, and ready. And status signal such as IO/M bar, SO, and S1. And DMA signals, hold and HLDA. In control signals, we are going to see about ALE. Can anyone say why ALE is used? What is the purpose of ALE?
To demultiplex, Cartesian type. To demultiplex.
Yes, you are right. Address latch enable is an active high signal which is used to demultiplex the multiplexed lower order and data bus. Next, if ALE is high, then the multiplexed bus carries the lower order address. Then if ALE is low, then the bus carries the data address. Now you can visual in this diagram. Whenever the CPU is trying to address the memory, the higher order address will be available here, and during the addressing the sir, am I audible, sir?
Yes, Sivakumar, you are audible. Continue.
Okay, sir. Okay, sir. Sir, during addressing the memory, the ALE latch gets enabled, and the lower order address will be available in this area. When after addressing the memory, when you try to read a data from the memory, the read signal will get enabled and the latch gets disabled, so there won't be any output available from this port. So the data will be available from D7 to D0. See, now D7 to D0 means it's a data bus, A7 to A0 is a lower order address bus, and A15 to A8 is an higher order address bus. Can anyone say why we are going for multiplexer in 8085?
Students kindly respond in chat. What Sivakumar asking is why multiplexing concept, time multiplexing concept is used in 8085 design. Cartesian typed to reduce number of pins, Sivakumar. Kritika
Yes,
typed.
correct.
Many of
Next,
them are
we are
typing.
going to see about read bar and write bar signals. Both read and write bar signals are active low signals which are used to perform the read and write operation. Can anyone say both these signals can active be at same time? Is both the signals are active at same time?
In classroom 2, Suggest typed no. In classroom 1,
Yes.
Dixon Locus Mega typed no. Antony Surya.
Yes, it's correct. Microprocessor cannot perform both the operations simultaneously. Either it can perform a read operation or a write operation. To read any data from the CPU, first it has to address the memory location. Then it can read the data from the memory. Or else it cannot perform both the operation at a simultaneous time. To read the data, RD bar should be enabled and WR bar should be disabled. And for writing the data, WR bar should be enabled and read bar should be disabled. While reading the data from the memory, the data from the memory will come through the data bus to the CPU. During the write operation, accumulated data gets stored in specified memory location. You should note the point here. Only after addressing the memory allocation, both the read and write operation can be performed. Am I clear?
Is it clear to all of you? What Sivakumar is telling is, after addressing the memory only, you can do either, the CPU can do either read or write operation.
Okay.
What about
Next
in
we are
classroom
going to
2?
see about
Yes, fine.
ready signal. Let us consider a scenario. Your processor is operating at a faster speed, but the device which you are connecting to the processor may be slower. Due to this, mismatch may occur. So when the peripheral devices is ready only, the input should be, sorry. When peripheral device is ready to accept the input, it gives the signal, I am ready. Or else it will provide, I am not ready to accept the signal or read the signal from IO device. So there will be a data loss. To overcome this issue, we are introducing a ready signal. Ready signal is an active I signal to the processor from the IO device. It is used to synchronize both the processor and input device. If input device is not ready, the ready signals pulls low and the CPU enters the wait state. During the wait state, the processor cannot perform any operation. Only when the ready signal goes high, the processor can read or write the data to input device or output device. Yes, now you can see the visual. Sir, is it visible, sir? Laser pointer?
Yes, your pointer is visible.
In this, both the microprocessor and IO devices have the pins to communicate with each other. The A15 to A0 is address, which is decoded by the address decoder, and it is sent to the chip select. Only when the chip select is enabled, you can perform these operations: read, write, and ready operation. Once the signal busy is given to the microprocessor, the CPU enters the wait state. Only after the busy signal becomes low, the ready signals will be enabled.
Shivakumar, actually busy is active low, correct?
Yes, sir. Yes, sir. Yes, sir.
Once the signal goes high, the processor can communicate.
Yes, sir. Yes, sir. Sorry, sir.
Okay, fine.
Now we are going to see about the status signals. There are three status signals, namely IO/M bar. So sorry, I forgot to place bar here. If IO/M bar is high, microprocessor is going to communicate with the input output device, or else it is going to communicate with the memory. By knowing these operations, the operation performed by the CPU, sir.
Yes, you continue.
Am I audible, sir?
Yes, you are audible, Shivakumar. You continue.
Okay, sir. Okay, sir. Okay, sir. I'm facing network issues, sir.
Okay, Shivakumar.
Based on the operation performed by the processor, the status of the S1 and S0 are as follows. Now you can see. During the halt operation, both the S1 and S0 are active low, so that the CPU is neither communicating with memory nor with the input output device. When S1 is 0 and S0 is 1, it is performing a write operation. When S1 is 1 and S0 is 0, it performing a read operation or reading a data from a memory. While both are S1 and S0 are equal to 1, it is fetching the opcode or else fetching the program from the memory. Okay guys, am I clear?
Yes, they are typing yes.
Okay. Now we are going to see on combining the all IO/M bar and S0 and S1 signals. Consider the scenario. During the opcode fetch, we are reading a memory so that the IO/M bar remains 0. You have seen the opcode fetch for during the last slide. so that S1 and S0 remains 1, so that the read operation is enabled. During memory read operation, IO/embargo is low, so that it is communicating with the memory. To have a read operation, S1 should be 1 and S0 should be 0. During memory write operation, same scenario. IO/embar goes low and the read bar is low. Read bar is high and the write operation takes place. During the input output read operation, IO gets active high, so that it can perform the input output read operation from the IO devices, as well as input output write operation. Interrupt acknowledge. It's a special kind of signal. Hello?
Yes, Shivakumar, you are audible. I think you are using mobile phone also with you. Okay, I think so.
No, sir. Sir, the room is echoing.
Okay, fine. You continue, Shivakumar.
Okay, sir. During the interrupt acknowledge, the IO device requests the CPU to perform the operation, so that the CPU perform the certain operation. For example, consider a scenario. You are playing a game and you will press a button, so that the CPU will respond the particular operation for that pressing the button. So the interrupt acknowledges. Hello? Sir?
Yes, Shivakumar, you are audible. You start presenting. We can hear you.
Disconnecting, sir.
Okay. Actually, your voice is audible in both classes. You continue.
Okay, sir. So that interrupt acknowledge is a read signal. Hello?
Yes, Shivakumar, you start continuing. Continuous பேசிட்டேருங்க. சரிங்களா? கேக்குதுங்களா?
Sir, இடையில disconnect ஆயிடுது sir. Mobile data off ஆயிடுது sir.
Okay, fine. But we can hear you continuously.
Okay, sir. Now, let's take the halt operation. During the halt operation, the CPU neither communicates with the memory nor with the input-output device. So it remains in the idle state. The hold operation will be explained in the DMA operation, and you can get a clear overview on hold operation. Reset is used to reset the microprocessor. Now, by using this IO, M bar, read bar and write bar, we can derive the memory read, memory write, IO read and IO write signal. For example, consider a scenario. You are going to read the data from the memory and store it in an accumulator. What is the instruction you need to type for them?
See, memory to accumulator.
Accumulator.
What Shivakumar is asking is memory to accumulator. You are asking instruction?
Yes, sir, instructions.
Okay, fine. Kindly type it in the chat, dear students. From memory to accumulator to load an 8-bit data, which instruction we have to use? Anthony Surya, kindly check. He is asking from memory to accumulator. Yes. To load an 8-bit data from memory to accumulator, which instruction we have to use? Yes, very good, Anthony Surya. She typed LDA address.
Yes, sir. Correct, sir. LDA ADR. During this LDA ADR operation, we are fetching the data from the memory. So the IO slash M bar remains 0. Read bar also 0. We are reading the memory. And write bar is 1. During this, memory read bar will be 0. Memory write bar will be 1. IO read bar is also 1. And IO write bar is also. Can you understand? During the read operation, read signal is 0 and we are fetching the memory, so IO slash M bar remains 0. We are not performing the write operation, so the write operation is 1. During the read operation, memory, we are going to read the data from the memory. So memory write bar gets low.
Shivakumar, there
We
is
are not
one
going to
question.
perform all these operations, so it remains as 1.
Shivakumar, there is one question. Can we use move A, M?
Sir?
Instead of LDA, can we use move A, M also?
Yes, sir. It is also, sir. No, sir. It is transferring between the registers.
No, move
Sir, yes, sir.
A,
Move A,
M.
M is, okay, sir. Okay, sir.
Okay.
Sir, I thought B register, sir.
No, move A, M.
Sir, move memory address pointed by the HL register.
Yes, very good, very good. Very good. You continue.
Now we are going to see the DMA signals. Can anyone justify what is happening in this diagram?
See, from this diagram, what you can able to understand, dear students, that's what Shivakumar is asking. Kindly respond to him. Yes, any answers?
Sir, shall I reveal?
Whether IO device ready or not, Karthikeyan typed.
Okay, it's correct. I'm not getting clear.
Okay, you continue, Shivakumar. No issues.
In this way, we are going to transfer the data from memory to IO device with the interruption of the microprocessor. So it is a slower process. So without getting the data into the CPU, we cannot transfer data to other peripheral device directly. To transfer the data from memory to IO device, microprocessor is essential. It's a slower process. To overcome this process, we have a solution called direct memory access. Direct memory access means we can transfer a large amount of data from memory to IO without the interruption of the CPU register. It means transferring the data directly from memory to IO device so that the CPU remains in the idle state or else hold state. Okay, now we can see about those signals, hold and HLDA. Hold is an active high input signal. Can anyone justify hold signal is generated by which device?
See, whether hold signal is generated by CPU or DMA controller. That's Shivakumar's question.
Yes, sir. Yes, sir.
Yes. Whether the DMA controller generates the hold signal or CPU generates the hold signal. Sajji's typed DMA.
Yes, sir. It's correct.
Shivakumar,
HLDA is the acknowledged signal.
Just a minute, Shivakumar.
Sir?
See, if you are going to ask too many questions, a lot of people have to present. You have to make the questions. You ask questions, but not at every stage. Just wherever you feel important, where the student has to understand little more deeper, there you ask questions, because a lot of them have to present. No, Right?
Okay, sir. Okay, sir.
Don't
Sure, sir.
misunderstand. Just take it in the right spirits. All
Okay,
of them are present. Just limit the number of questions. Okay?
Okay, sir.
Okay. Thank you.
Okay, sir. These signals are used for transferring the data from memory to I/O. When DMA is required, the input peripheral device sends an acknowledge signal so that the DMA controller sends the whole signal to the CPU. After acknowledging the signal, the CPU sends the HLDA signal to the DMA controller. After the HLDA acknowledges signal is given to DMA controller, all the control bus, data bus, and the address bus are given to DMA controller. So that only after completing the DMA operation, the bus are given back to the processor. Now you can see the flowchart of the DMA operation. Now first DMA requests the CPU. So that after the DMA is requesting the CPU send an acknowledgement signal HLDA. After the acknowledgement signal is given to the DMA controller, it addresses the memory and transfers the data. Only after the transfer is complete, it will terminate the DMA. Till this time, the who is master and who is slave?
See, during DMA operation, which one is going to be master and which one is going to be slave? Yes, any answers? See, during DMA operation, the bus control is with whom? Yes, DMA is master, CPU is slave. Very good.
Yes, sir. Correct, sir. Only after the DMA operation is completed, the bus control is given back to the processor again. Till that, the DMA holds the system bus.
How does the processor know that DMA operation is over?
Sir, once the whole signal gets released,
Okay, the signal, whole signal will turn from 1 to 0, right?
yes, sir.
Okay, thank you.
Now you can clearly visualize what are the DMA operation going to perform here. Now the address bus, data bus, and control bus are in the control of the microprocessor. The address bus of the processor is connected to the memory address bus, as well as the data bus to the memory data bus, and the control bus to the memory's control bus. Now, whenever the input-output device is I/O device is used to perform the DMA operation, it sends a signal through DREQ port. After acknowledging, the DMA controller will send the signal hold to the microprocessor. After the microprocessor acknowledge the whole signal, it will provide a HLDA signal to DMA controller so that you can take over the bus control. After HLDA is acknowledged, the arrow shifts downwards so that all the buses are in the control of DMA controller. Once the DMA operation is completed, the bus access will be given back again to the microprocessor. Till the DMA operation, the bus control remains under the DMA controller, so that the data transfer can takes place between via this data bus. Guys, am I clear?
Students? Yes.
Yes, sir. Sir?
Okay, fine. Bimal? Is there any question from students? Students, any questions to him?
Ram sir, I have a question.
Okay, okay.
Yes.
If no students is asking, I'm asking. Shivkumar, you said ALE means time multiplex. Time multiplex. What do you mean by?
Sir, echoing, sir.
I am closing my voice on the other tab because if I speak from two tabs, then you will give me disturbed. So I'm just talking to you only through A class. Ram sir, the class B ku mundu neenga apra convey pannidunga.
Okay, sir. Okay, sir.
Time multiplexing nu sonneenga. What do you mean by time multiplexing? ALE signal is time multiplexed அப்படினீங்க.
Sir, during which operation, sir?
நீ தான் சொன்ன ALE signal is time multiplexed. உன்னோட ஸ்லைட் ஷோலயே இருந்தது.
Yes, sir. Yes, sir.
அப்ப டைம் மல்டிப்ளெக்ஸ்ங்கிற வார்த்தைக்கு என்ன அர்த்தம்?
Sir, already the pins are multiplexed in the microprocessor, sir. Sir, by using the ALE only, we can demultiplex the lower order address bus and data bus, sir.
Time multiplexed. What's the meaning of the time multiplexed?
It's a sequential operation, sir.
நான் கார்னர் பண்றேன்லாம் நினைச்சுக்க வேண்டாம். இப்படி கேட்கறதுனால உனக்கு இன்னைக்கு அந்த அர்த்தம் அதுக்கு இது தெரியும். அதுக்கோசரம் தான் கேட்கிறேன். என்ன you don't feel offended, right?
No, sir. No, sir. No, sir.
The students in second.
So the sequence of operation.
You continue, Shivkumar.
Sir, during the ALE operation, first we have to address the memory locations, sir. Only then we can transfer the data to the specified memory location. During that addressing the memory location, address is a 16-bit data. So in this first port, we have the higher order address bus. During the addressing data, ALE gets enabled and the lower order address will be stored in the A7 to A0. So that we can address the memory location, sir. Only after addressing, we can read the data and store it in the specified memory location, sir. It's a sequence of operations, sir.
இது வந்து demultiplexing, right?
Yes, sir.
ஆனா டைம் மல்டிப்ளெக்சிங்கிற வார்த்தை தானே யூஸ் பண்ணிருக்கீங்க நீங்க.
Sir, time multiplexer வந்து sir in the address and data bus are connected together, sir.
Okay, great.
To reduce the size of pins available in the microprocessor.
Fine. What is the use of the word time there? That is by construction they have reduced the number of pins, right?
Yes, sir.
உனக்கு கொஞ்சம் டைம் தரேன். இது எப்படின்னா யூ கெட் பேக் டு மீ ஆஃப்டர் உனக்கு வந்து அந்த இது நடத்துவாங்க, டைமிங் டயக்ராம்லாம் நடத்துவாங்க. அதுக்கப்புறம் நீ எனக்கு பதில் சொல்லு போதும். சரியா?
Okay, sir. Okay, sir.
Right?
Thank you, sir.
இரு தப்பிச்சு ஓடாத இரு. உனக்கு இது தெரிஞ்சிருக்கலாம், சொல்லிருக்கலாம் ராம் சார், நீ கவனிச்சிருப்பியான்னு தெரியல எனக்கு. ஐஓ அட்ரஸ் எழுதுற போது ரைட், CPU is writing an IO address னு வச்சுக்கலாம். IO அட்ரஸ் எத்தனை பிட் அட்ரஸ்? 16 பிட்டா 8 பிட்டா?
Sir, 8-bit address.
சரி, அப்போ A50 லோயர் பைட்ல இருக்குமா ஹையர் பைட்ல இருக்குமா? லோயர் ஆர்டர் அட்ரஸ் பஸ்ல இருக்குமா ஹையர் ஆர்டர் அட்ரஸ் பஸ்ல இருக்குமா? அது இல்ல ரெண்டுத்துலயுமே இருக்குமா?
Sir, higher order address.
சும்மா சொல்லக்கூடாது.
Okay, sir.
சரி, இது நீ கண்டுபிடிச்சு சொல்லணும். நிறைய பேர் இருக்காங்க கிளாஸ்ல, அதனால நான் இப்பவே சொல்லிடுறேன். யூசுவலி இட் இஸ் லோயர் ஆர்டர் அட்ரஸ் பஸ், பட் ஆனா நம்ம ஹையர் ஆர்டரையும் எடுத்து யூஸ் பண்ண முடியும். ஏன்னா CPU வந்து லோயர் ஆர்டர்ல என்ன கொடுக்குதோ அப்படியே ஹையர் ஆர்டர்லயே அதே அட்ரஸையும் டிரான்ஸ்மிட் பண்ணும். சரியா? ஜென்ரலா பட் எல்லாருமே சாதாரணமா லோயர் ஆர்டர் அட்ரஸ் பஸ் தான் எடுத்து யூஸ் பண்ணுவாங்க. ராம் சார், am I right?
Yes, sir. See, when CPU addresses the IO device, specifically when executing in and out instruction. Okay, when executing in and out instruction, the IO device has to be addressed. IO device address is 8-bit, so it is sent in both higher order address bus as well as lower order address bus, as sir told. But usually we will take lower order address bus.
See, these are the small tricky things, right? எல்லாத்தையுமே வந்து கிளாஸ்ல சொல்ற போது சிலது கவனிப்போம், சிலது கவனிக்க மாட்டோம். பட் இந்த மாதிரி ட்ரிக்கி திங்ஸ்க்கெல்லாம் தான் கொஸ்டின் வந்து அந்த மார்க் டெஸ்ட்ல இருக்கு, ரைட்? நிறைய கொஸ்டின்ஸ் பாத்தீங்கன்னா அதுல வந்து ஐ எம் செட்டில் வித் மை குவிஸ் அப்படின்னா யூ கேன் செட்டில் வித் மை குவிஸ்ல வந்து செட்டில் ஆயிக்கலாம். பட் இந்த மாதிரி கொஞ்சம் ட்ரிக்கி திங்ஸ் எல்லாமும் கத்துக்கணும் அப்படின்னா ப்ளீஸ் டேக் த மார்க் டெஸ்ட். தேங்க்யூ சிவகுமார். நீ வந்து அந்த பதில் யூ ஹாவ் டு கெட் பேக் டு ராம் சார் ஆஃப்டர் டைம் மல்டிப்ளெக்ஸ்னா என்னங்கிறதுக்கு நீ சொன்னேன்னா அன்னைக்கு கிளாஸ்ல ராம் சாரும் அதை எக்ஸ்பிளைன் பண்ணுவார். சரியா? we will wait for 1 or 2 classes. அந்த டைமிங் டயகிராம் கிளாஸ் நடக்கிற வரைக்கும் கொஞ்சம் வெயிட் பண்ணலாம். அப்போ உனக்கு இன்னும் கிளியரா புரியுதான்னு பார்த்துட்டு அப்புறம் பேசலாம். அதர்வைஸ் வெல் பிரசன்டட். Thank you so much.
Thank you, sir. Thank you
Shivakumar.
Cooperation, guys.
Thank you, Shivakumar. Your session was very
Thank
good.
you,
Okay. Vimal, can you start now? Shivakumar, you can stop presenting and you can remove
Okay,
from classroom 2.
Okay, sir.
Sir, am I audible in both classes, sir?
Wait a minute, Vimal. Yes, I think you are audible in both the classes.
Yes, sir. I am presenting now, sir.
Okay, fine. Yes, we can see your screen. Vimal, we can see your screen.
Yes, sir. I am going.
You also present in classroom 1. Yes, both classes it is visible. Fine.
Okay, okay, sir.
You can continue, Vimal.
Pleasant morning to all. And now I am going to explain you about arithmetic logic units and clock signals. In clock signals, I am going to explain you about reset signals and clock signals and reset signals. Okay. Can I know? First, we say ALU as a mathematical brain of a computer. Can anyone say that? Why do we say ALU as the mathematical brain of computer? At the first time explaining you that ALU means arithmetic and logic unit. In that ALU, what task do we perform? We perform arithmetic operations in our ALU. So arithmetic operations means mathematical tasks. So we say that ALU is the mathematical brain of our computer. In the second point, we have given that the main purpose of ALU is to process the data and perform arithmetic and logic operations. Right. The main block of ALU includes accumulator, flag registers, and temporary register blocks. This is the diagram of the ALU, in which we have accumulator, temporary registers, and flag registers. Yes, in the ALU, in 8085 microprocessor, in the ALU we do not have any storage facility, so we need a temporary storage the registers to store our data which we process in our ALU. We have 2 inputs, which is accumulator and the other is temporary registers. These 2 are for the storage purpose, which we process the data to the ALU. The result is stored in the accumulator. The arithmetic, the following are the arithmetic operations which can be performed using the ALU operations: 8-bit addition and 16-bit addition, 2-bit BCD additions, 8-bit binary subtraction with or without borrow, binary logics, or and nor, not and or XOR operations, bit shift operations. Yes. Now I'm going to timing and control signals. In which timing and control signals, I'm going to explain about clock out and reset signals. Clock signals. Yes. In this, we are saying that clock pulse is the heartbeat of microprocessor. For humans, we say this clock pulse is the heartbeat of a microprocessor because if clock pulse is not at functioning, any task cannot be performed because if a task is performing, we need a particular time to perform the task, right? So without the particular time measurement, we cannot perform a task. If this clock pulse is collapsed, the entire performance entire program will be disturbed. It is used to the control and synchronize the operations of the processes. As I said, it controls means uses the time and controls uses the time to measures and updates the operations to the processes. The clock signals determines the time taken by the process to perform an operations. Other point is the crystal frequency is twice the operating frequency of the microprocessor. I've given a diagram here. In this, the 3 megahertz is the crystal frequency, and 6 megahertz is the operating frequency.
Vimal, I think you are telling in the reverse order.
Yes, sir. Sorry, sir. Yes, sir. Crystal is 6 megahertz, and the operating frequency is 3 megahertz. As I said in the previous slide, I have given that crystal frequency should be twice the operating frequency of the microprocessor. The clock out is used to synchronize the peripheral interface with the processor. Peripherals, can I know what is meant by peripherals?
Any answer? Peripherals means what? Suggest typed IO devices. Shivakumar typed IO devices.
Yes, peripherals is out. It takes the performance task performed by the IO devices to the processors. This is the main uses of clock out. The frequency of clock out is equal to the operating of frequency of the CPU, because when the clock out is performing some task, it should match the operating frequency of the CPU, or the entire task will be collapsed. Like if some is lagging and some is going faster, the total task will be getting low. Reset signals. The reset signals are reset in and reset out. Reset in is active low input signals. Can someone say that why reset signal is reset in is known as active low input signals?
See, he asked one good question. Vimal asked one good question. Okay, why the resetting signal of the 8085 microprocessor is active low?
If it is difficult in typing, someone can unmute and speak.
Shivakumar typed if it is active high, the CPU remains in off state.
The pin is pulled low in the reset in when the it comes from low to high, so we call it as active low input signals. When we pull it low, the microprocessor gets resetted not only the processor, it resets all the peripheral devices which is connected to the CPU or the processors. Yes. The reset out is active high output signals, which is totally opposite to the reset in. Reset out is high, and it is the peripherals are connected to the reset out signals and resets the signals. After resetting with the reset in signals, the primary address or the base address goes to the 000H, which is a hexadecimal number, and it performs from the beginning of a particular task or program. The proper way of resetting is we should hold the resetting button for at least 3 clock cycles. Yes, we have a diagram here. In this diagram, what do you remember that it represents?
See, what about
What
this
do you
circuit?
Sir?
You are asking about the reset circuit?
Yes, sir. The way it is designed, sir. I'm asking.
Okay,
Like,
what you are inferring from this image? That's what he is asking.
Yes, I'm going in.
Okay, you can continue.
Yes. The peripherals are the devices which are externally connected. It is connected to the processors or CPU, like our PC setups. We have a PC setups in which we connect our external devices like keyboards, mouse, and printers, scanners, etc. The same way, this is connected. Yes, power on reset circuits of 8085 microprocessor. This is a power on reset circuit of 8085 microprocessor. In this, yes, we have RC network built with resistor 1 and capacitor 1 here. In this, the R1 is at the value of 75 kilo ohms, and C1 is in the value of 1 microfarad. When we push this push button for at least of 75 milliseconds, that is 3 clock cycles, this RC network gets activated, and it pushes the current to the reset in, and it performs the reset task, which brings the microprocessors to the original memory 0000H. This is what I have given this. After 75 milliseconds, the capacitor charges to the maximum voltage of 5 volt, which pulls the reset in pin of 8085 to high, and it resets the CPU to the original memory of 00H. Thank you, sir.
Vimal, 2 question.
Yes, sir.
First வந்து ALU ல ஒரு arithmetic operation பண்றோம்னு வச்சுக்கலாம், right? Add bean பண்ணலாம்னு வச்சுக்கலாம். So ALU is going to give me என்னென்ன கொடுக்கும் ALU? Result, status of the result. 2 possibility இருக்கு இல்லையா?
Yes, sir.
Result எங்க இருக்கும்? Status of the result எங்க இருக்கும்?
It will be in the accumulator, sir, and the status of the results will be in the temporary registers, sir.
அப்படியா? ரிசல்ட் எங்க இருக்கும்?
Accumulators, sir.
அப்புறம் flag registerல என்ன இருக்கும்? Flag register தான் the status of the result.
Yes, sir.
Flag register will have the status of the result, right? சரி, இது ஒண்ணு. ரெண்டாவது வந்து இருங்க, ஒரு கடைசி டாபிக் என்ன சொன்னீங்க? இது ஆர்சி சாரி ரீசெட் சர்க்யூட். ஓகே, சரி, அவ்வளவுதாங்க. I forgot that question. Thank you. வேற யாராவது கேட்கலாம் கேட்கலாம்.
Students, is there any questions from your side to Vimal? No. Okay. Vimal, you can stop presenting.
Yes, sir. Thank you, sir.
Nicely
Thank you, Vimal.
Thank you.
சார் ஆர்கிடெக்சர் டைம் பத்தாதுன்னு நினைக்கிறேங்க சார். சஜஸ்ட் சொல்லிருக்கோம்.
இன்னும் எத்தனை பேர் இருக்காங்க?
இன்னும் ஒரே ஒரு ஆள் மட்டும் பிரசன்ட் பண்ணுங்க சார்.
ஏதாவது ஒரு கிளாஸ்ல லாஸ்ட் 10 மினிட்ஸோ இல்ல ஃபர்ஸ்ட் 10 மினிட்ஸோ கொடுத்துருங்க சார்.
ஓகே சார், ஓகே சார்.
ப்ராபபிலி மண்டே கிளாஸ் இல்ல நினைக்கிறேன். டியூஸ்டே கிளாஸ்ல வேணா ஃபர்ஸ்ட் 10 மினிட்ஸ் அவங்க ரெஸ்ட்ரிக்ட் them to 10 minutes.
ஓகே
so
சார்.
that class time பெருசா இதாகாத மாதிரி.
ஓகே சார்.
Okay.
Okay.
Thank you all.
Thank you those who have presented today. Okay, the session was very nice. We hope those people who presented, you can realize, okay, when your friends are not responding properly, how you feel? Any idea? See, நம்ம பாடம் எடுக்கிறப்போ நம்ம ஃப்ரெண்ட்ஸ் ஆன்சர் பண்ண மாட்டோம், கரெக்டா?